Hello friends, and welcome to SaiCad Center, our SolidWorks online training program in day 2. And before we start, I want to introduce you myself. My name is Setu Nandania, and I am Autodesk PTC and Dassault certified instructor. And before we continue, please mute yourself, okay, as we all know. So we do not have any kind of voice disturbance. If you have any query regarding my screen is not visible to you or I'm not properly audible, okay, so you can unmute yourself and ask me, or you can type your message in the chat box. So let we begin with the SolidWorks. So here I'm sharing my SolidWorks screen. Yes, here we are. So today we are going to learn our two new tools, that is extrusion and revolve, and also extrusion cut and revolve cut. These both tools are very important because they are the core tools to create any kind of component. So mainly we can say around 60 to 70% work we do with these tools, because it's that much simple and we can create many types of drawings with the help of that. So now see, let me learn that tool first. So I'm going to the part file, and here in the feature we have our first tool, extrusion. And what is the output of this tool? We use this tool to provide some height to our sketch. Again, we use this tool to provide some height to our sketch. So select this extrusion. Now we have to sketch first. So select the top plane, and here I am creating just a simple rectangle. Let me add some dimensions also, because I like these fully defined sketches. So we added these dimensions and finish it. So as you are going to finish this command, you will notice that it's going to extrude. The sketch is start taking height, and all the settings will be on the left side. See, the main benefit of SolidWorks software is you do not need to find other options or some other tools anywhere. Whatever you have selected, all the settings and parameter will be over here on the left side. So we just need to learn only this much tool step by step, very slowly. Okay, so first we have direction 1 over here. See, direction 1, that means this object is taking height in some direction, and this is the value, this much height it is taking. We can increase and decrease and also type our own value, that 45 or 50 or whatever. So that much height it will take. Now for example, I want this height on the bottom side of this sketch, right? So we want to flip this. So this is our flip button, reverse direction button. So click on that and your extrusion height will be reversed. Again click, so it will be reversed. So this entire thing that we discussed now, it's covered in blind extrusion. Blind means a single direction extrusion. Okay, we have one more option over here. We have actually many options, we will discuss this, but focus on this last one, mid plane. So if you choose this mid plane option, then we do not have that reverse option, we cannot reverse it. And whatever height we have written over here, for example 50, so half will be on the one side and half will be on the other side. Total height will be this much, whatever we have written. Right now it is 50. So half will be on one side and half will be other side. Here we can say half will be on top and half will be on bottom. So we do not have that flip option in the mid plane. And also we do not have direction 2 option. See, like direction 1, we have direction 2 over here, but while we are in mid plane, we do not have that option. Let me again switch to the blind. So go to the blind. So here we have flip option, also in direction 1, and also we have direction 2. For example, we provide 50 mm height on the top side, but I also want 10 mm height on the bottom side or 20 mm height on the bottom side. So turn on this direction 2, so opposite side will also going to active, and you can provide your value over there that I want 20 on the other side and 50 on this side. Still we have a flip option over here. So if you click on the flip, your direction 1 will be opposite side and direction 2 will be also going to flip. Both will be flipped. Okay. So upside will be down. So in this way you can use this both tool. Now if you don't need direction 2, you can turn off. We also have some other options. Next we have this draft. So if you want a taper angle, if you want to add some draft angle to your object, then turn on this draft and provide your draft angle, for example 10 degree. So our all the faces will take a 10 degree angle inward. Instead of going straight, it is shrinking down, as you all can see. See, all the sides at 10 degree. So now if we increase the height, our cross section will going to reduce. So this is due to taper angle. Similarly, if you want this angle outward, we have draft outward option. So click on this draft outward. So this taper angle will be outside. So our cross section will be increased as we go further. It is clear up to this point. Similarly, on the other side, we also able to apply the different draft angle. See, direction 2, and in this direction 2, I don't want to apply any draft angle. It is also fine. For example, I want to apply a draft angle of 30 degree over there. Also outward or inward. So all the settings we have. Then hit OK and your solid part will be created. Clear?
Yes, sir.
Okay. Now again, let me delete this. See, this is our feature manager where our all the operations will be listed. Right now we have extrusion 1, and in this extrusion 1 we have our sketch. Okay. So I'm selecting this extrusion 1, right click and going to delete it. While deleting this feature, I'm not selecting this option. See, we have one option over here, delete absorbed feature. So if I select this option, our sketch is also going to delete, because sketch is the absorbed feature by this extrusion. So uncheck this button and click OK. So now we have work sketch. So we can use this sketch to again extrusion purpose. So first you can create sketch and then you can use this extrusion, or we can create first extrusion then sketch. So vice versa, both are possible in this software. So extrusion, and now I'm selecting this sketch because I have. So this is taking height, but this time I don't want a solid object. I want a thin feature object. So over here at the last we have thin feature option. So if you click on the thin feature, our solid will be now taking only thickness. Whatever lines we have will take only thickness, and thickness value you can type over here. Let's say 5 mm. So it will take only 5 mm thickness, but this thickness is outside from our sketch. So if you want to flip the side, you can with the help of this reverse direction. So it's inside, this is outside. Also we have midplane option. So whatever thickness you have given will be half inside and half outside from your sketch. And also we have a two direction option. So in the two direction you can provide two values. So this T2 is for inside and this T1 is for outside. Okay, so total thickness over here we have 15. Hit OK. So your name over here is Extrude Thin 1. Focus on this name. What is this name? Extrude Thin 1. Okay, and now let we edit this object. So right click and go to the edit. Now we are not able to switch to the solid mode. We are not able to turn off this thin feature. Okay, we cannot turn off this thin feature. For example, I want my full solid object back, so we cannot flip once we complete this command. See, I have turned off this thin feature. In some version or in some software you can uncheck this button, but when you press OK, your output will be there as it is, right? Nothing will be changed. So again, if you want a full solid, you need to delete it, and again you have to extrude it. For the first time we have option that I want a full solid or a thin feature, but once you active your thin feature and finish your command, your object will always remain in thin feature. For example, I am going to turn off this thin feature, and once I finish my command while I am in solid model, say I am going to finish this. So over here my name is Bose Extrude. That means now we do not have that option for the thin feature. Again, let me enter in this extrusion. So right click and click on this edit feature. So again you enter in, and as you notice that we do not have that thin feature option. So we cannot toggle between solid and thin feature. That thing you have to keep in your mind. Okay, एक बार आपने इसे सॉलिड में एक्सट्रूड कर दिया तो ये सॉलिड में ही रहेगा, और थिन फीचर में एक्सट्रूड किया तो ये थिन फीचर में ही रहेगा. ठीक है.
Yes, sir.
Okay, now let me discuss the other options. Again, let me take extrusion. This time we can use any solid face to sketch. We also have our standard plane, but it is not visible right now. So you will find that over here, front plane, top plane, right plane. Okay, so you can select it from here, but I want to sketch on this face. So select it, and as you all see that we have our UCS over here, press Ctrl 8 to take it in front of you. Now I'm creating couple of rectangles over here. And finish it. So again it is going to extrude, right? Let me provide the height over here, 100. Okay, and here we have a new option. See, merge result. If you turn off this, then your new solid will not going to merge with the older one. Okay, so we have a clear line over here, as you all can see. This is known as split line. So this solid is different, this solid is different. So in the solid bodies we have five solid: 1, 2, 3, 4 and 5. So these are the five solids we have. But again edit it and turn on this merge result. So what will happen, it will try to merge with the other solid. Click OK. So again, as you all can see, we do not have a partition line over here, right? So this is a single object. Now we have no multiple solid body, we have only single solid body. Now again extrusion on this face, control 8, and here I am creating a sketch. See, as I told you, I generally use to create a fully defined sketch. The reason you will learn right now. See, for example, I am providing a diameter 50. This point control and the center point vertical, and we are placing this circle over here. Okay, so we haven't create a fully defined sketch right now. We have one dimension missing, this vertical position. Okay, then finish it. Now this circle is going to extrude. Okay, I want to change the direction on the other side. Okay, and now we are going to discuss the rest of the options. That we have. So see, first option we have over here. So these are the options are for reference extrusion. This blind means you can provide your own value, but for example you don't have any kind of value. For example, I don't know at which distance this face is appearing, right? So I don't know the gap between this circle and this face. So at that time we can use our references. So the rest of the options are for the references. So our first reference is through all. So in that case, extrusion feature will automatically decide that how up to which point I have to go. So it will reach up to the final edge of the solid, that is through all. Then next option we have up to next. So in that case it will stop when it reach the first surface, when it will get a solid geometry in their path, it will stop at the first face. So that is up to next. Through all means it will go to the last edge. Through up to next, that means it will stop at the first face. We also have a freedom for selection. That means we have two options for that: up to vertex and up to surface. Up to vertex, you have to define a vertex point. For example, I want to go up to this point. So see, your extrusion will take height up to that point. If you go with the up to surface, you have to provide a face or a surface. That I want to go up to this face. So it will take height up to that face. For example, you want some offset over here, starting offset. Then also we have a option offset from surface. So choose this and provide your offset, for example 5 mm. So see, we have selected this face and our extrusion stops before 5 mm. we reach up to that face, before we reach, it stops at the 5 mm. You can change your offset. You can reverse your offset also, that after that phase I want to go 15 mm further. So clear, these are the options through all, up to last stage, up to next, to stop at the first phase, then vertex and surface to provide the reference that we need to go up to this point, and offset from surface. We have up to body, but right now we have a single body, so you can, it will stop at the first phase. So let me take up to surface, and I want to go up to this phase. Now we have couple of settings for the starting position also. So go to the from, and here we have sketch plane option. That means our extrusion will start where we have created a sketch, but I want some offset, so you can use offset. Let's say 20 mm, enter. So see, sketch is over here, but extrusion is start 20 mm offsets. We can create this kind of scenario with the direction 2 also, but we can flip the offset also. See, but this thing we cannot create with the direction 2, right? So if you want some offset between your extrusion feature and your sketch, then you can use this offset. We also have a reference option over here: surface, face, plane or vertex. So click on surface, face and plane, and for example I want to start my extrusion from this face. So see, sketch over here, but extrusion will take place from this face and stop at this face. So everything is on reference. Click on OK. So I hope you all got my point. It is clear now?
Yes, sir.
Okay, good. Now see,
Yes, sir.
as you all know, in our last extrusion, we have created a underdefined sketch, right? So as you all know that this is a parametric modeling software. That means we have created a 3 extrusion operation over here, and all 3 are listed over here. See, and somehow, for example, I have decided to change this thickness. Instead of this 50 mm, I just want 15 mm. By mistake I enter 50. So we can easily edit that. See, right click on your feature, whatever feature you want to edit, go to the edit feature if you want to edit your feature. If you want to edit your sketch, then go to the edit sketch. So if you want to change your sketch, you can go to the edit sketch, and here you can change your sketch also. Like this, I have changed my sketch. Finish it. Your object will be updated, right? And if you want to change the feature, that height, so go to the right click and edit feature. We have two options, right? So edit feature, instead of this 50 I just want 15, right? So I, by mistake I have entered 50, so I change it and finish it. So as you all can see, our this extrusion stick on this face, so this thing come down with this face, but this feature doesn't come. Are you getting me?
Yes, sir. Yes, sir.
So why this solid, this extrusion 4 doesn't come, doesn't follow this thing? because that is not a fully defined sketch. See, for example, go to the sketch, and for example, I have entered a value over here, that smart dimension center point from this top edge should be always at a 75 mm distance. Okay, so I have entered one value over here, that this center point must be 75 mm away from this edge. See, this top one edge. So now this sketch is fully defined. So what will happen now? This this extrusion 4 is also going to follow my instructions. See, I am going to change the height again 50. So this phase is rise. So this extrusion is also raised, and this extrusion is also raised. So that's the reason why I use my fully defined sketch. If you haven't a fully
Okay,
defined
sir.
sketch, and if you are going to change something in your previous result, your next operation may create some error.
Okay, sir.
See, again, I am removing this dimension. Finish. And I am going to decrease the height. So the top feature, our last feature, will not follow that. Control Z, and it may create some error also. See, we have to decrease the diameter, let's say 30. Finish. And now edit feature, and we want 5 mm. So see, now we have a two solid body over here. This object is completely separate. So that is why I always use a fully defined sketch, and that's why I'm recommending you to use this fully defined sketch. Now let me discuss extrusion cut. So again, delete this. We have a circle, and click on this extruded cut. Select your sketch, and it will try to cut your object. So whatever solid this operation is going to intersect will be removed. See, I have provided 100 value for the blind. Hit OK. So it will remove that solid, whatever comes in their way. And we have all the options like extrusion in the extrusion cut also. See, we have through all option. So it will go up to the final edge. Click OK. So it will create a through all cut, right? If you use up to next, then it will stop after one piece. So once it cuts a single object, then it will stop automatically. So that is up to next. Then we have up to vertex. You can provide a point that up to this point I want to go. Up to surface you have to go up to this face. So it will cut these three plates. So all the options we have draft angle also, outward and inward. Hit OK. So your taper extrusion cut will be there. So these are the options we have. And a last option in the extrusion cut, that is extrusion cut on this face. Control 8. I'm creating a new sketch. Okay, so generally what will happen if we choose this blind cut, see, 25 mm. So this cut will create this type of output, right? So whatever portion inside our sketch will be going to remove up to 25 mm. But we have one option over here. Go to the edit feature and we have that option flip side to cut. So if you turn on this, so except this inside area, the outside all the volume is going to remove. See, output will be flipped. Whatever portion we have inside that sketch will be there, and all the outside portion will be going to cut. So that is flip side to cut. So I hope this extrusion and extrusion cut, both the options are clear now. Do you have any question? Okay. Now let me take one example with the extrusion. So I am giving you option. Um, you have to choose that which example do you want to see. Okay. So just a minute. I am sharing you that assignment. Are you able to see the screen? This drawing sheet.
Yes, sir.
Okay. So here you have couple of options. We have a very simple object over here, little complicated, right? So these are the two examples, and also you have this type of examples. So which example do you want to see? We have this one, and this one is also that you have seen in the assignment. Okay. So these are the options you have. So we have one suggestion, third one, this one.
Third one, sir. Third one.
Third one. Okay, so
Yes, sir. Third one.
no problem. Complicated. See, for me, no one is the complicated one. So it may be complicated for you, but for me, all are the easy one. No problem. We are discussing this third problem. Okay. So before we start, we have to plan little. See, for example, we have to create this object. So first of all, what we will do? So we need to fit that data in our mind, that this operation that I will do first, then I will do this one, then I will do this one. So in this way we have to plan first. So here from this isometric view, I'm going to show you what we will do first. So we will create one sketch on the front plane for this. See, this sketch we will create only this much. Okay, and then we will give a height. So this solid will be created up to this base plate, right? So this solid will be created. So that will be our first operation. Okay, this portion we will sketch and we will give a height, whatever height we have. So this L portion will be created. Then we will create this sketch, this circular sketch, and also will give height. Then we will create this slot and also create this circle. Okay, so up to this point we have cleared. So now let me check the dimension. So here we have dimension. So what is our first sketch? So just focus only on that dimension. Okay, not all the dimension. We have to create these things. See, we are just interested in only this area. So only focus that dimension that are related with us. So we have a horizontal length 140 mm, thickness over here 20 mm, angle over here 60 mm. Then we need this length also. So let me check from view B. View B is this one. So this length is 90 mm, right? So this one is 90 mm, angle is 60. This thickness is also 20 because both are same. Okay. So that dimensions are enough. Let me go to the SolidWorks screen. A new part. Okay. And here sketch on the front plane. And let me draw first randomly. Okay. So the horizontal line, then vertical line, then here, then we'll go around here like this and this point. In this case, these both are horizontal and these both should be parallel. So add a parallel relation over here, parallel. Okay, good. Now dimension. So this line is 140. This thickness is 20. This thickness is also 20. Then angle over here. So this one 60 degree and inclined length 90. So we have done this sketch. Finish it. And now to provide height, we need to find the thickness. So see in the side view over here, we have 60 mm. So this thickness is 60 mm. So we have to extrude it 60 mm. So go to the feature, extrusion 60 mm. But I will choose midplane option over here. Okay. So we have done this thing. Now next we have to create one over here, this piece, top piece. So let me check the dimension for that. So for this we have thickness 20 mm, which is fine, but for the dimension we have to view from C. So where is view C? View B, view C. View C is over here. So this center point from the final edge is 60 mm and the radius is also 30, which is okay. Okay, that's it. And 20 mm thickness. So extrusion on this face, control 8. Here we have a corner, rectangle, and a arc. Or you can create circle also. and dimension this center from this line is 60. In the center we have a hole of 15 mm diameter, so let me create one hole. The diameter is 15 and finish. Now this is 20 mm, so the extrusion height is 20 and flip it inside. Okay, done. Then next we have to cut a slot over here and a circle over here. So the width of that slot, this slot is 20 mm. See over here it is written 20 mm and the depth is 5 mm. This one. And the diameter of this circle is 30 mm and depth is 10 mm. Okay. So extrusion cut on this face, Control 8. First we will create a circle. The diameter is 30 mm. Finish. And the depth is 10 mm. Okay. Done. Now we have to create that slot. So again extrusion cut on the same face. We will create one rectangle like this. Smart dimension. Width is 20 mm and it should be at center, so we will give a half distance 10 mm. So now it is in properly in center. Make sure this rectangle is bigger than our geometry, so we are taking a 5 mm this side and randomly 110 mm length. Okay, make sure just this rectangle is bigger than our geometry. Finish. And depth 5 mm. Okay, so it start taking shape, right? Then we are going to create this slot back side. So sketch will be created on the top plane. We will create one sketch, 42 mm, angle is 60 and depth is 6 mm. Okay, everything is there. So again extrusion cut on this face, Control 8. Here we have one line, midpoint line from here. Okay. Now smart dimension, the length of this line is 42. Make sure you have a midpoint line. Then angle between this line and this line, this angle should be 60. And this bow gap is 6 mm. And one more thing, the length of these both line are equal. Okay, finish it and it will go up to all, through all, take through all over here. Okay, so we create this slot. Then we have two holes over here, right? Let me check the dimension for that hole. So it's in view B. Here we have the two circles. From this slot we have 35 and 25 and the diameter is 10 mm and through hole. Okay, so extrusion cut on this face, control 8, and here we have two circles, 1 and 2, both are in same line with the origin, so all are vertical, both are equal, so select and click equal relation, and now dimension. So we have provided equal relation, so we provide only a dimension for one circle, so another will automatically the same. Now from this line and this point is 35, and this center point and this center point is 25. So we have fully defined circle. Finish, and it is throughout, so we can take this through all. Okay, done. Now lastly we have this centerpiece that we need to finish. Let me plan for that. So here we have that sketch. So if you want to create this thing, you have to sketch over here in this side. Okay, so from this view we will create a sketch, 30 mm in the center, 15 mm, and the height is 30 mm. Okay, so let me sketch it first, then we will extrude 50 mm. This gap is 16 and this one is 4 mm, so total 20 mm offset over here. Then we have 50 mm extrusion. See over here, you will get the idea. Extrusion, on this face, control 8, one rectangle, one arc, a trim, and dimension, this should be 30, so the half distance will be 15. The height of this circle from here is also 30. Okay, so we have fully defined sketch. Now finish it. Okay, so height we have to provide over here is 50. We are on wrong direction, so flip it, and from our sketch our offset is 20 mm, so take a offset over here from sketch 20 mm, flip that offset. Done. Okay, then again extrusion, because we have to take 4 mm this side and 4 mm this side, that small circle, right? So for that I am creating sketch, circle, finish, and this height should be only 4 mm. So extrusion 1, 4, so this is 4 mm. On the other side we want 50 plus 4, so total 54. So on the direction 2 we will add 54 and finish it. So see, we have both side 4 mm extra. Now we have one small hole, diameter is 15 and that is throughout. So again extrusion cut, on this face, control 8, a circle diameter is 15 and finish it. We will go up to next, not all. Okay, otherwise it will cut this portion also. If you go through all, this face is also going to cut. So go up to next and okay. And lastly, we have to cut one slot over here. So that is 20 mm width, okay, and 19 mm from this face. Right, it is 19, okay, 19. And the depth over here is 35. So 15 minus 35. So from the bottom we have 10 mm. Okay. So again, extrusion cut on this face. Control it. One rectangle. Start dimension. This should be 20 mm. This line from this 19 mm and this line from bottom is 10 mm. Okay. Take through all both sides. Okay. So here it is our object. So we have created many extrusion operation, many extrusion cut, as you all can see, right? So you have to plan everything, that I will do this thing first, then I will do this one, then I will do this one. So at the end I will get this result. Clear now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
So can you explain the last portion alone, sir?
Sorry.
Can you just explain the last portion alone, the last extrusion part?
Last extrusion.
Yeah, can you tell it once again, sir?
Okay, this one, this extrusion cut.
Yeah, yes, sir, yes, sir.
Okay. So I have create one sketch on this face, and then I took this extrusion cut like this. But I took through all from here through all. So it will cut this portion, this center portion, whatever solid is intersecting. So it will be removed from this.
Okay, sir. Sir, I have a small query.
Yes.
Sir, I'm not able to install SolidWorks latest version. That is the biggest problem I'm facing right now.
What is your error message?
One second, sir. Because I tried it 4 to 5 times, sir, but I was just getting the same thing again and again.
Okay.
Sir, actually, it says that my configuration toolbox has been successfully installed, but my SolidWorks, the main software, has not yet been installed, sir. So when I checked for the online solution, it gave me one solution, sir. Like I'm supposed to go into the settings of my laptop and then change it. And finally, I did
No,
all
no, no,
those
no,
things,
no,
but
don't do
still,
that.
I'm not.
See, any solution you find from
Yes, sir.
net that you take you to the control panel. Please don't do that if you don't know about the control panel properly. Okay, otherwise your computer system will be in trouble. So if you have any kind of problem with the software, maybe your problem with the your OS, or maybe some other problem, but try to use the older version. It is also fine. You don't need to always install a latest one.
Okay.
Try to use the older
When I'm
version.
when I'm requesting for a software, it's giving me only two options: 2019 version and 2018 version.
So go for
So which one
2018.
should I choose?
See,
Okay.
there is a reason behind that. If you use older
Okay.
version, then it will run in your computer system smoothly. This latest version
Okay.
consumes more power of your processor, needs more graphics card, and needs more RAM, right?
Okay,
And
sir.
we are not having that much facilities in new version. Whatever in new version is also available in the older version also, but it
Okay, sir.
consumes very less power and less processor, so it will run smoothly in your computer.
Okay, sir. Okay.
Okay, now let me discuss our next tool. Just a minute. So our next tool is
So,
revolve tool. Yes.
sir, I have a doubt.
Yes,
Sir,
please.
actually, what is the difference between the planes, sir? Front plane and the top plane we use?
What is the difference between front plane, top plane, and right plane? Are you asking that?
Yes, sir. So one time we are using a front plane and another time using top plane. What is the difference and why should we use the top plane for this and front plane for that?
Okay. Just a minute. Just a minute. My system is taking too much load due to this WebEx browser. So I am just restarting the SolidWorks software. Okay. Meanwhile, let me take your attendance. I am also taking your attendance. Oh. So how was our session going?
Yeah, sir, it's fine.
It's
And
good,
the
sir.
schedule is
Session,
for us.
the session is really informative, so we are getting to know about many tools, what are all the advantages of this software, the uses, apps and other things. So it's really informative for us. So only thing is we have to practice it many times, many diagrams, then we can master this software easily.
Thank you so much. Okay, so now we are going to discuss our next tool, Revolve tool. I hope this SolidWorks screen is visible. So there is a very small and a tiny difference between extrusion and revolve tool. And that is, in the extrusion, our sketch takes a straight height, but in the revolve, our sketch will take a revolving height. See the example, you will get the answer. So choose revolve. Okay, before we start, we have one question, that is why we have three planes, front plane, top plane, and right plane, right? Uh,
Yes, sir. Yes.
yes, that is because we are in 3D. You can start your work from any plane, that doesn't matter, but we are in 3D environment. See, let me take this permanently in the screen. So we are in 3D. So this face is known as top plane because we view that plane from the top view. That's why its name is top, right? Similarly, we have a front plane. So because we view it from the front. So these are the views, nothing else. But in the 3D environment, we have a three standard plane. This plane is known as standard plane. This is your origin of your file. This centerpiece is origin of your file, right? And these are the three planes. These are the standard plane. It is not necessary to start always from the top plane or front plane or a right plane. We also able to create our custom plane using this plane tool. We will discuss that later, but we have, because we are in 3D environment. If we are in 2D, then we have only single plane. Okay, it's not a big confusion between this, why we have these three planes, so don't worry about that. Just sketch it on anywhere. For example, revolve, I want on right plane, then you choose right plane, nothing else. Okay, so for the revolve feature, we need two things. We need one revolving axis. So let me create one center line over here, and we need one sketch to revolve. Okay, so here we have a close sketch, and here is the revolving axis. Now for the revolve feature, you need to keep one thing in your mind, that whenever you are using your revolve feature, your cross section should not cross your revolve line. Okay, otherwise you will get nothing. This will not accepted.
Yes, sir.
So
Yes,
your
sir.
cross section must be on the one side of your revolve axis. Then finish it and you will get the result. This is the output of the revolve feature. Finish it.
Can you do it and show me again, please?
Yes, I know. See, let me edit it, how this thing is created, right? So here instead of height, see in the extrusion we do extrusion operation, it will take a straight height over here like this, right? But in the revolve we have degree over here, see, degree angle, let's say 90 degree. So in this case, this sketch is taking angle around this axis and creating a solid like this, see, like this. Now understood the difference between extrusion and revolve?
Yes, sir.
So this is in the revolve feature, it will take angle around your revolve axis. See, this is my revolve axis. So if you view it from this angle, so you will get the exact idea that we are taking a angle around this axis. See, clear? So this is revolve feature. Over here you can provide your revolve angle that I want 120 degree revolution. We have flip option also on the opposite side revolution, this side revolution. We have midplane option also. So whatever angle is there, half will be other side and half will be this side. So everything is like extrusion. We have thin feature option also, but once we finish this, we have vanished, right? So let me delete this and again revolve. So 180 degree other side, and here we have thin feature option also, 2 mm thickness, inside outside, right? So all the options like extrusion we have, but this is revolve thin, so now we are not able to switch to the solid feature. See, again go to the edit, and now you are not able to uncheck this button. It will always remain in thin feature. Once you create this thing in solid, it will always remain in solid, right? But for the revolve, as I told you, only one condition is there. Our solid, our cross section must not cross our solid. Say 180 degree. Okay. So here we have to choose our revolving axis. By default we have one center line, so scale this software have assumed that this must be our revolving line, but we can define our own. See, just right click over here and clear this selection, and I will say that I want a revolve axis as a this line, so this will be my revolve axis. So my sketch will take angle around that axis, see, like this. Clear? So we can use our sketch edge also for the revolve. For example, I want a revolve axis, this one. So my sketch will take angle around that, like this. Clear? We can use this one also. It will take angle like this, right? But we are not able to take this edge. See, focus over here. We are not able to take this edge. Why? Because if we choose this edge as a axis of revolution, this edge is crossing our cross section, so we will not get any kind of preview for this line. We are not able to revolve. Similarly, this line is also not able to use as a revolving line. We cannot use this line also as a revolving axis. If, see, one more thing over here, if this line is going to cross over here, then this line is also not useful for revolve axis. But we are getting preview, that means this line is not going to intersect. So in this way you can choose any line for the revolve axis, but condition is only one: your revolve axis must not cross with your cross section. Let's say 360-degree revolution and finish. So now I hope you all get my point, that why we get this type of shape. Okay. Similarly, on the other side we have revolved cut. So click on the revolved cut. Let me take a front plane this time. We will place our revolving axis over here for construction, and my cross section should be circle. I want to cut one circle over here like this, and also want to add one ellipse. Finish it, and you will get a revolving feature like this, right? It is revolving around this axis that we have created. But as you finish this thing, because we have a revolve cut operation, so it will create a groove over there, that type of groove. Whatever solid is going to touch that revolution will be removed. Let me show you again. Edit. This time I am using 180 degrees, so you will get exact idea. See, we have this much revolution, and as I finish, you will get the result. So this much volume is going to remove due to this revolving cut operation. So it is clear now. Revolve and revolve cut.
Yes, sir.
Okay. So in your first assignment, we have that flywheel, right? That you have to create with the revolve. So how you will create that? Let me show you. So I hope this screen is visible.
Yes, sir, it is visible.
Okay. So first of all, we will create one revolve. Okay. For that, we will create this half cross section, this much thing we will create. So for that, we will create one axis over here, then the sketch, and all the dimension that we are going to provide over here will be our half dimension. Okay. So let me begin. Then we will check this dimension frequently over here. Otherwise, we are going to confuse between sketch and dimension. No problem. SolidWorks screen is visible.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So here we are taking a sketch. Which plane do you want? Tell me. On which plane we want to sketch?
Front plane.
Front plane, sir.
Front plane. Okay, chalo. Front plane. Here we have a construction line for revolving axis, and midpoint line from here like this, then this, and Then we have like this here and here. Okay, this point press Control and this center point vertical, and the dimension for this is 50 mm. Okay, good. Let me do mirror. So mirror entities, for this much things about this one. Okay, so a sketch is good. Now let me add one by one, step by step dimension. So we'll start from the center. So the smallest diameter over here is 60 mm diameter. So we have to provide the half value, right? So this line from here is 30 mm. Then next, this point, up to this point we have 100 mm. So yes, okay, that one. So this point from here is 50. Then angle is 60 degree. So this line with this line is 60 degree. Then we have this point 380. So for this point from here 380 by 2 and 400 for this point 200. Okay, now the thickness is 10 mm and this gap is 35. So this line from this center is 5 mm, so thickness is 10 mm, and the length of this line is 35. So everything black in color, that's good. And last we have one arc over there, that dimension is missing. So we have one arc like this, and the diameter for radius for this arc is 500. So it will look almost flat. Okay, radius is 500, so it will almost look flat. So this is our section and revolving axis. Just finish it and go to the revolve. Revolving axis, we have two center lines. See, SolidWorks is again going to confuse. We have created two center line, so he didn't choose any one as a center revolving axis. Got it? So here we have to specify that this one is my revolving axis. Okay, so we have this wheel. Now the rest of the part is extrusion cut. So first of all we will create this thing. We have 1 2 3 4 5 and 6 divisions, so every division is in 60 degree angle. Yes, so we have to calculate this thing, my friend. So 60 degree angle we have. Okay, so see how to create that thing. Go to the extrusion cut on this face, control it. Here first of all we will create a center lines. So one is horizontal, one is here and one is here, and give dimension. These two at 30 degree and these two at 30 degree. Okay. Now the two circles 1 and 2 and diameter 81.5 for the inside radius and for the outside 165. Okay, so circle from here and here to here, 165. So the diameter is 165 into 2 and the inside one 81.5. So the diameter for this is 81.5 into 2. Okay. Now the thickness of this thing is 15 mm. Okay, so we have to take offset of 7.5. Good. So we will create one line, or we can use offset also, but I am using line tool. This line and this line parallel. This line and this line are also parallel. And smart dimension gap between these two lines is 7.5. See, if you have any confusion, you can immediately ask me. Okay, 7.5. Now with the trim tool, trim this portion, trim this portion, trim this one, and trim this one. Okay. Now again, these both arc are free, so place their dimension 81.5 and 165. Okay, good. Now at the end we have a fillet of 30 mm at this point, at this point, at this point, and also at this point. Okay, done. Now you can take a circular pattern. So go to the circular pattern about this point, number of copies 6, and entities to pattern, select step by step this arc, this one, this one, this one, this one, yes, this one, and this. So we have 6 copies. Click OK and finish it, and take up to next. Okay.
Sir, can you repeat it again, that before that fillet option?
Which
I
one?
mean, how to draw that?
Which
Sir,
one?
before that fillet, sir, just now did I fillet one, sir?
Hmm.
Fillet. So before that, I mean, how you drawn that? Yes.
This thing is clear up to this point.
No, sir, I want to know about that only. I mean, how you drawn that?
So
This
can you
thing.
draw that arc and show once again, sir?
Yes, sir.
Okay. Up to this point, it is clear. I have created three center lines over here.
Yes, sir. Yes, sir. That's clear, sir.
Okay.
Yes, sir.
Okay. Now I'm taking circle. Yes, we have taken a circle, one circle and two circle. 165 into 2. Okay, and then you can take offset 7.5 of this line, this side, and this line again offset this line, this side. Okay, we have taken a 7.5 mm offset. Now I use trim tool to trim this rest of the portion. Trim. I have trimmed this circle because I don't need that. Trim this portion also and this portion. Here, this one and this corner. After that, I have this much area. Center point of all these arc are over here. Okay, and it is fixed. This should be 81.5 mm radius and this should be 165 mm radius. Clear?
Yes, sir.
Yes, sir. Thank you, sir.
Okay, then flat 30 mm and then you can use pattern. Or we have a circular pattern over here also, which we will discuss later because it's a part modeling feature. So here is our axis and we can create a feature also. So 6 copies. Similarly, you have to create one hole. Okay, one hole over here and take a circular copy. So your object is finished. So it is clear?
Yes, sir.
Good.
Yes, sir.
So I hope you also like our today's session or just get bored.
Yes, I would like.
Okay, so that's it for today. It is enough for today now. If you have any confusion, then we will discuss. Now you can ask me whatever question you have.
Sir, about the tested assignment, the first diagram you said you will write.
Actually, I don't have your today's assignment. I forgot to take
No,
it
sir,
from the file.
yesterday.
In the yesterday's assignment, what is the question?
Yeah, yes, sir.
What
In
is
that yesterday's assignment,
huh?
the first diagram, sir.
First diagram? Yes, for
Yes, sir.
sketching purpose. Yes, yes, yes. Thank you for reminding me. Okay,
Yes, sir.
we
Thank you, sir.
discuss that. So you are talking about this, right?
Yeah, so that one is.
So let me go to the SolidWorks. New part.
சரிங்களா கேக்குறீங்களா சரி வாங்க சரி
Creating
சும்மா
one
வந்து ஒரு வாட்டி
sketch.
வாங்க நீங்க வந்து பாருங்க ஒரு வாட்டி
Not on this. Let me create sketch on top line. Okay. So first of all, we will create this center line because we have a circle over here. So, and we will keep this circle at the center. So here is our center line for construction and midplane line. Okay. Now the diameter of this circle radius is 25. So this length is 25 mm. So we have something like this. Smart dimension. This should be 25. Then this we have 35. So this point from here is 35. Then we have from here to this corner point 75. So this is 75. And then we have
So that 75 is from before that one point. So
yeah. So
yeah,
look at
that's 75.
this. So this thing from here.
Yes, sir.
And also we have one center line at here. So let me create that. This line should be horizontal and this line should be vertical. Okay, good. One line for construction between here and here. Okay. Now this dimension is 100 mm, right? So this is 100 mm. And this is 12 mm. So from here to here is 12 mm. Understood? Understood?
Yes, sir. Yes, sir. Yes, sir.
sir.
Yes, sir. We understand.
So what about the dimension before the 35 mm?
Before this 35, this one,
Yes, sir.
that is we have taken 25 because it's a 25 mm radius. See this 25 mm radius. So from center, this line will be 25 mm distance.
Okay, okay.
Clear?
Yes, sir.
That dimension is taken from this drawing, 25. So this thing is 25. Okay, you are talking about this, right? Whatever I have selected.
Yes, sir.
Okay, that
Yes,
will
sir.
be
Yes, sir.
25. Same over here. This
Okay.
we have considered 12 mm because over here we have 12 mm radius. See, so from the center, this last point will be 12 mm distance. So this will be our 12 mm. So we have given that dimension. Now the thickness is 14. So let me take the vertical dimension sum. So this is 14. Make sure your line is at the center middle, otherwise we need to provide some more dimension. Again 60, so from this point to this line will be 30, and thickness is 8 mm, so this one is 8 mm. Okay, done up to this point. And now we will take a mirror.
Angle.
Which angle?
Degree, 30 degrees, sir.
Over here?
Yes. From the top to bottom. See. 60 degree. Total 60 degree of 30.
Oh, this one.
Yes.
See, our sketch is already fully defined. Okay. So if it is not necessary to add that dimension, then please do not add. Let me check what angle we are getting over here. So from this we have 29.9, means almost 30 we have. Clear? So if you want to enter that value, you need to remove something. Then and then you are able to provide that value. Now 30. So this value is accepted right now. Understood? So any one value you have to consider.
Okay.
So let me go with our this one 75 and select this mirror, about to mirror this one. Okay, and extend this line. Now we will create one line like this, one line like this, and this and this are parallel. These are also parallel. Okay. So smart dimension gap between these two is 8 mm. Over here we also have 8 mm. Okay. And at last, fillet, how much over here? 10 mm between this line and this line. Okay, done. And then add the rest fillet. 20 over here, 10 over here, 20 over here outside. So 10 mm will be over here and here. Okay, and 20 will be here, 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 and here. Okay, done.
Sir, I'm having some basic questions. Can I ask?
Yes, please.
Sir, like I'm basically lacking in one thing, sir. I'm not able to read the engineering diagrams properly. I'm not able to understand the geometry, the dimensions properly, sir. So, which can you suggest any book for me to read and get to know those things properly?
See, that is the skill that will automatically develop when you practice. Okay, how to read this drawing is also depend on your practice.
Okay.
Okay, so try to read everything from the drawing. See, this is not just like a sketch. Now you are an engineer. Okay, now you are not a student from the school. So this is not a painting or a drawing for you. This is a engineering document, and just not just do not focus on the shapes and curves and all. Focus on this text, each and every text. What are these things written over here, why it is written. Nothing is uh, not a single word will be over here which is useless. Are you getting my point?
Okay.
So
Yes, sir.
always read engineering drawing as a drawing, not as a picture or a sketch. So everything, whatever dimension, see this much, this is the very biggest text written over here. So you need to understand why they write this much things. For example, 06 dash diameter 20 through at PCD diameter 340 EQSP. So each and every word means something over here. Let me explain you what does this thing means. So we have 06. That means we have 6 copies of this, right? So
Okay.
this single sentence is representing all these 6 cows, these 6 holes. So that is why I haven't provided any dimension on the rest 5. I have put only one notice on this, and that will affect all the 6 hole. So we have 6 copies and diameter is 20 and depth is
Okay.
through. So this hole is throughout. Okay.
Okay.
Then
Okay.
PCD means pitch circle diameter. So from center to the distance of this circle, see this dotted red circle, that is known as PCD, and diameter for that is 340. So what will be the center to center distance? A distance from this center and a circle of this will be the half of this much, right?
170.
Yes, 170 will be there from this center point to this center point.
Yes,
And
sir.
four and one more note is over here. See, EQSP, that means equal spacing. So we have to take a circular pattern to create this 6 hole with equal spacing. So the gap between this two circle, this subsequent two circle will be equal.
Okay.
So just don't focus on the sketch. Just read each and every instructions written over here. That is our engineering drawing.
Okay. 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 So I have one more question.
Yes.
After drawing a sketch in SolidWorks, can we generate the CNC codes for it?
What? CNC codes.
Yes, sir.
CAM module is actually available in the SolidWorks, but generally it is not preferable because people are using that NX CAM and Master CAM and all for programming purpose, right? So for that you can use this model also. Just transfer your model to the step file and open that model into the other software where you want to program. You can use this model definitely, 100% you can use this model for your CAM purpose.
Oh, okay. Okay.
So I hope you get the exact thing. And do you have any question now?
No, sir.
Yes. Hello.
No, sir. No.
Assignment for this today's session, sir. What about today's assignment?
Yes. How was our today's session?
Yes, sir, it's fine. It's really usable.
Okay. So see you on Saturday.
Really.
Attendance.
Is there any assignment for today, sir?
Assignment will be sent it to your WhatsApp group. Okay.
Yeah.
You will get that in
Okay,
your
sir.
WhatsApp group.
Attendance, sir. Attendance.
Attendance is taken, my friend. So you are over here for the attendance. Huh? You are over here for the attendance only?
No, sir.
Okay. Okay, friends. Then see you on Saturday.
Okay, sir. Thank you.
Yes,
Okay,
sir.
sir.
Thank you.
sir.
Okay, sir. Thank you.
Bye.
అయిపోయిందమ్మా